Okay, this is 3-1, and we are actually going to be solving systems in 3 different ways. This is basically an entire chapter in Algebra 1 that we're going to do in one lesson. So, hang on, here we go. The first thing we're going to look at is looking at systems of equations. Now, a system is where you have two equations. It's essentially two lines, and you want to know where they cross. So we want to know if something are solutions to the system. For it to be a solution to the system, it needs to work in both equations. So every equation, or not every equation, every point is x comma y. So I want to fill it in. I want to fill the -1 in where the x is, and the -4 in where the y is. So that'll be -3 plus 4. 1. Is 1 1? Well, yeah, last time I checked. Then we have -1 minus -4. -1 plus 4. Does 3 equal 3? Well, yes, it does. So that one works. Okay. Now I'll test 1, 2. So it'll be 3 times 1 minus 2. So 3 minus 2 is 1. It worked in that one. And 1 plus 2 is 3. It worked in that one. I did something wrong. It looks like they both work. But that usually doesn't happen unless I did something wrong. If you see my mistake, you need to holler at me and be like, Miss Tucker, you did something wrong here. Let me pause it. I found my mistake. It's right here. That should be a plus sign. -1 plus -4 is not 3. It's -5. Does not equal 3. So this one did not work. No. So this one didn't work. This one did. So 1, 2 is a solution to the system. Wow. I'm sleepy. I'm recording this the day before it's supposed to snow, so I get sleepy. Now, example 2, we have to graph these two lines, and we want to know where they cross. So, the best thing for me to do, I've got 3x plus y equals 10. Now, normally I would graph that using intercepts because it's in ax plus by equals c. It's in standard form. But 3 doesn't go into 10, and that's going to get ugly really fast. So what I'm going to do is I'm going to solve it for y. So y equals -3x plus 10. So that means I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go down 3 over 1. Down 3 over 1. And go ahead and just put a whole bunch of points on there. And connect them as best you can. Okay. And then I have x minus 4y equals 12 minus x. So -4y equals -x plus 12. And then I would divide by -4 all the way across. So y, a negative divided by a negative, is a positive, and that's 1/4. And then, 12 divided by -4 is -3. So I'm going to begin at -3, and I'm going to go up 1 over 4. Up 1 over 4. And what happens is these two lines cross right there. So that point is the answer. So that's at the point 1, 2, 3, 4, -2. 4, -2. And that's the answer to the system. Now it says solve, tell me how many solutions the system has. Well, if I graph these, I'm going to have to solve them for y, minus x. So I got -3y equals -x minus 1, divided by -3, all the way across. So y equals 1/3 x. Oh no, plus 1/3. And then minus x, so -3y equals -x plus 1, divided by -3, divided by -3, divided by -3. Y equals 1/3 x minus 1/3. Now I want you to look at these two equations here. I've got 1/3 x plus 1/3, 1/3 x minus 1/3. What do you notice? Right there. The slopes are the same. If the slopes are the same, without even graphing these, the slopes are the same. I'm going to have parallel lines. I'm going to have up 1 over 3. I'm going to have this line at about 1/3, and then down here at about negative 1/3. I know that I'm not actually graphing it right, but I'm just giving you, because 1/3 is hard to graph. These are parallel lines. So the question is, if they're parallel, do they ever cross? No. So they have no solution because they never cross. This one, if I solve it for x, if I add x to both sides, I would have negative 3y is x minus 1 divided by negative 3 all the way across. So y is negative 1/3 x plus 1/3. That's what I had over there, almost. Minus 3x. Plus y is negative 3x. Oh, I'm so sorry, I'm tired. Oh my gosh. Divided by 9. So y is, those reduce to negative 1/3 and 1/3. And what do you notice about these? They're the same. So it's actually the same line. You graph this line, you graph it again, and it would be about here, down 1/3. I'm actually graphing it correctly. I would graph that line twice. So I graph it once, I graph it again. Where do they cross? They cross everywhere, so they have many solutions. Oh, sleepy. Actually, skip this one because I didn't give you a graph. Yeah, skip that because I didn't give you a graph. And then it says, tell how many solutions the linear system has. Well, let's solve it for y. This would be 2/3 x, negative 2/3 x plus 2 if you move it to the other side. And then if I do minus 4x, y equals negative 2/3 x plus 2. What do you notice about them? They're the same. Yay. So it has many solutions. Yep. And then this is just what we just said. This one has one solution. This has infinitely many solutions, and this has no solution. You're putting a fence around a rectangular yard, and you want the length. Oh, there's this question again. Here's the width. Here's the length. You want the length to be twice the width. You will use 120 feet of fencing. What are the dimensions of the fence? We have done this question. So we do 2w plus w plus w plus 2w equals 120. 2, 3, 4. Oh, I have to stop this one here in a minute. I can't. W equals 20, so 2 times 20. We might do this in pieces anyways. So the length is 40 and the width is 20, because I don't think I'm doing a good job explaining stuff because I'm about to fall asleep. Yeah, we're going to stop this video there with graphing, and then we'll pick back up with substitution on the next video.